Let's move on. We're going to talk about a geotechnical module. This is a quick agenda we're going to go through. So first of all, what is the geotechnical module? And then we'll go in and actually look at the nitty-gritty of how it works, how it creates projects and how to import data using the location and strata manager. We have the ability to create geotechnical profiles, so we'll be showing that. A quick look at the styles and hatching. And if we get time, I want to show you really the fundamentals of how to model geology inside AutoCAD Civil. It'll only be a quick look, but hopefully it will set you in the right direction. And the final few minutes will just be looking at if the geotechnical module doesn't quite do everything you want, other options you have moving forward from there. So what is the geotechnical module? Well, it's an enhancement for AutoCAD Civil 3D. It's actually supplied by Autodesk, but it actually happens to be developed by my company, Keynetix. It has in it various things. It has like a simple project manager where you can import CSV data, AGS data into a project. Once that project has been created, you can link through to it in any drawing and bring those 3D borings and boreholes into your drawing to work with. So as you start creating boreholes, you can see here we've got my apologies by the way to everybody, I will by mistake flip from boreholes to borings, perhaps the odd well, so I jump between different terms, but primarily I think most people in the US would normally call them borings, so it's boring data that we can show either in plan or, as you can see here, in model space in 3D boring holes that you can see here. We'll go on and see how we can generate civil 3D surfaces from the materials down the borings, so you can see it and visualize it. From that, we can look at how to generate geotechnical profile views. A little look at our hatch and style manager interfaces, and then on from there. So to start with, to get hold of the geotechnical module, all you need to do is go onto your Autodesk subscription site. Okay, so just pop up there and we should see your subscription. You just literally click on AutoCAD Civil 3D. As you click on that, it pops up the new, so it's a different position for where it was for the Geotechnical Module 2016. So you click on the downloads, click on update and add-ons, and you should see the Geotechnical Module listed there. So you can just literally download it, and it's just a 1 minute, 2 minute install to get it in and working on your machine. Okay. So we're going to start off now by asking it to create a project and import the data, and what I'm going to do is I'm going to do it all for real. I'm going to import it all and go through the whole process, but before we do that we need to look at the formats of the data it imports. Now this is the important thing. This is the hard thing to get right. If you get it right, it makes life so much easier further down the road. So for the geotechnical module to import, you need to import data. You can generate these in Excel if you like, but these 3 files: location details file, field geology descriptions, and potentially, you don't need the third one, orientation and inclination. So I'm just going to go through and show you what they are. Now the file names and the case with these are important. The point is once you get the format right, you can just use it. It makes it easy for you to use it time and time again. So this is the location details. So this basically gives information of where each one of your borings is. So each boring will have its own unique ID. So you need like boring hole 001. The boring type, so this is whether it's rotary core, perhaps a test pit. It's really just so you can manage your data better within the actual geotechnical module. You can type in like TP for test pit, for instance. Where they are, the eastings and the northings, so whichever coordinate systems you happen to be using in, and finally the ground level itself, so what we're talking about here is, I'm talking American now, so the Z value as opposed to the Z value. So it's important you get that right, because obviously you're doing a nice accurate model, that information has to be pulled in at the right location. So that's the main sort of set of data for telling you where each boring is. So it would look like this. You can see the boring ID. Each one of these is unique. The type of boring it's going to be, northings and eastings, and ground level. The second compulsory file, the one you need, is what we call the field geology descriptions. So in here, very quickly, a location ID. So this is your boring ID, the ones we just seen. So boring BH001. You then have pairs of depths going down. So it will be sort of from 0 down to 3 is where you may have topsoil. From 3 down to something else is where you have another geology. So you have a top depth and a base depth. You need the two. Then the final bit here is really your lithology, your geology codes, whatever you want to call your individual materials down. Now you could just create one value, just call it geology codes, but you notice we've got 3 boxes here. We actually allow you, perhaps you have your soil classification you want to put in there, you want to put in a rock classification, you want a combined one with both sets of data together in one. So what you can do is basically use any of these 3 any way you want, but at least one of them must be populated. And I'll show you what we mean by that. So here we have, so for boring 1, from depth 0 to 0.5, we're going to call it TS for legend code is topsoil. Consider your legend code your soil classification code, if you like, but we're going to give it a nice descriptive name in geology code of topsoil. We then go down to the next piece of geology material below it, which is 0.5 to 5, and we're calling that sand. So as you can see, as we go down, we have the soil classification together with sort of a lithology name we're calling it. The point where we have 2 or 3, you don't have to have them, is that inside the geotechnical module, you can choose which one you want to band and display. Okay, so it sort of gives you more flexibility with the software. The third file, and this is an optional file, you don't need to have this one, is in case you've got an inclined borehole. So this is a borehole, instead of going straight down, it goes in the ground at an angle. Okay, so again, you need your identifier, your boring ID, which is the same numbers we used beforehand for each borehole. Then we have an orientation. Now you imagine you're looking down on plan from above, and it says which direction is the borehole going in. Is it going north? Is it going east? And you just enter an angle to represent that. The last number here is inclination, which is really the angle in which it's going into the ground. So here the thing to remember that if you are going to have these records, you're going to import them, going straight down is actually 90 degrees, not 0. Okay, some people going all 0, 0, 0, and you end up having horizontal boreholes. And if you type in -90, you'll have a borehole going up. So unless you've got some fancy rig and you're drilling inside a cave, I don't think you do that very often. So to show you that information here, you see, so here we have an inclined borehole. So the orientation is 20 degrees, so that would be sort of on our compass going up in this direction, and it's going down into the ground at 165 degrees, you can see there. So they're the 3 files that we need, or 2 we need, and the third one is optional. So once we've got that, we can actually start working and looking at importing that into the system. So the way we do it is we're going to go into the Geotechnical Module in AutoCAD in a moment. We're going to connect through to our database. We're going to create a new project, then import the data. So let's do that now. Just bear with me a moment while I'll go and fire up AutoCAD. Here we go. Let's use the Imperial one. Geotechnical Module will work with both metric and Imperial. Okay, so we're in here now, and we're going to go to the Geotechnical Module tab, which is this one here, and you see that we have this connect button. So first of all, what we're going to do is connect through to the database. And the database is always a local database on the machine where you're running Geotechnical Module. So we click on connect, and it comes. I've got lots of other stuff on my machine, so ignore all this stuff here. You'll have this one here called Geotechnical Module 2017. There's no username, no password. All we do is hit login, and it's making my AutoCAD session connect through into my Geotechnical Module database. And in here I have a whole host of different projects I could call upon and bring in here. So for instance, I could just click on one of these projects now and go open. And because I've already created this project, the data is already here, I can just bring it straight in for use. Okay. So I'm just going to undo that for now. I'm just going to create a new drawing and just show you actually how to create the project and bring it all in. Just open up a new drawing. So we're going to hit connect again, but this time I'm going to go and click on create. So let's create ourselves a ASTI 001 project. Okay, this is the ASTI example. We have a couple of fields down here we have to fill in. These can, using the manage button, you can change the lookup values and things in here. This is primarily so that when you sort, you can go and find your particular project you want to work on. So for now, I'm just going to use the default settings until it's a current open project, and I haven't even got any categories in here at the moment, so I'm just going to set it to default. All of these other fields here are just optional. Type them in, and it means you can actually search on that data at a later date to find the appropriate project. I'm not doing that for now. So let's just hit save on there. So what we've done now is created ourselves a new project. There we go. And I could edit the details or delete it if I want, or if I hit OK now, we've now created this project placeholder. So it's a little bit like creating a surface inside Civil 3D. You tell it to create a surface, but you can't see it. There's no data there first until you start adding data into that surface. And it's the same logic here with the Geotechnical Module. We've created our project. I now have to go to import data into it. So you can see we've got CSV. I'm going to use the default mapping, which I've just explained to you a moment ago with those CSV files. There is a slightly different format for the very early versions of the Geotechnical Module, so we'll ignore that. We're talking to Americans, so comma separated files do use a comma, and you may or may not use double quotes. The interesting thing is many parts of the world, comma separated files do not use commas. So always confuses me. So we're going to hit add, and we're going to go and pick our files we're going to use to add into here. So just bear with me a moment while I find my data for this presentation. So there's my 3 files. So I'm just going to select the 3 files and hit open, and we'll go through this little wizard now. So it's just checking the contents of my files. It likes the look of them. It's giving me the option now to bring in all of my boreholes, so I could tell it if I wanted to, don't bring in the particular borings. I hit next. It's going to tell me now I'm about to bring in 18 boring locations. We've got 87 different strata values in it, and finally that's it done. So there is my data imported into my current session, ready for me to go. So once we've done this, I could go to a new drawing now, open up a new drawing, and all I need to do is connect to this project, and these boreholes would come in very fast into the session. Okay. So we've gone through here, we've pulled in the data. We now can look at this data and work out how we want to display it using the location and strata manager. So this is the location manager. I won't do a tour on it. I'll get straight into the software to show you how it all works. So we're going to have a little look at the location manager, and then we're going to go on and look at the strata manager. So let's go back into AutoCAD now. So we've pulled in these boreholes. First thing to show you very, very quickly is my colleague who's trying to talk to me, that he's on holiday in Australia at the moment. So what we're going to do here first of all is go to Home, go to layer properties, and you'll see that as we pull this data in, we're actually putting it onto different layers. Now, I've done a cardinal sin here, is I always, when I train people on how to do this, always tell them you need to have your site drawings there, you need to have your DTMs, you need to have sort of full model information around you, so that when you bring your geotechnical data in, you're seeing it in context with what you're looking at or hoping to build or what's been on the site in previous. Because then the big advantage is if I just quickly go through my site here, I can turn off all the data. Then we can come in here and say, okay, where is the sand across the site? Now, if you've got peat, if you've got material that's going to cause problems, it's a real quick way of seeing where those materials are in context with the whole of your site. So imagine you've got, someone sent you 50 boring logs. You either got to sit through and look and study each one boring log, or you just load it in here, and in seconds you can actually start visualizing where your different geologies is across your site. So that's a big positive. But if I go into the geotechnical module, I can click on locations now, and this is the location manager. It controls what I see on screen. So for instance, remember when we talked about the files we can import? I mentioned that we could import data using the geology code or legend code. Can you see if I pick on another value how it suddenly changes? Or we could use soil classification. In fact, that's not set in my particular data I've pulled in, so it's showing it all as blank. So geology code, so it's really using that data we've imported to display how we're showing the boreholes. The next one along here just quickly shows what vertical exaggeration I want to use. I've just zoomed out a place there, so let's bring that back in. So now you notice my boreholes are at 1:1, so at the true depth of what the boreholes are actually being drilled at on screen. Okay. So I normally like working, at least in these webinars, with them at 5-fold vertical exaggeration, so we can actually at least see what we've got there. We also have down here a record for each one of my boring locations. So if I pick on one, I can come over here and decide which elements of the boring I want to show. So we have model, we have plan, and we also have another one which I'll show you in a moment when we're in plan, which is the log strip itself. So we can choose which ones we want to look at. So if I now quickly flip back to top view and go to 2D wireframe, I could come in here now and use this select from drawing, perhaps pick the boreholes at the top of my site, so you can see those ones being selected here, and tell it go and generate me a borehole log strip for those ones. So in a very few seconds we now have a boring log based on the data we imported being shown against each one of my boreholes. It's a great way when I'm looking around my site, having a look at what geology we have around the whole site. So it's a quick, easy way of doing it. We also have another option. If you imported the data and you suddenly realize, oh, that's the wrong data, or I really don't like the look of that data I've just imported, perhaps these 4 boreholes we've just looked at here, we don't like the look of, I can click on this button here to say to them, hey, don't include them, ignore them, pretend they don't exist, okay? And any work we'll do from now on will just ignore those boreholes. But at a future date, I could just bring them back if I wanted to. So this is the location manager, and it really controls which boring locations you want to show on your drawing and what data you want to include within the session. Where things get fun, if this is the type of fun you like, is when we click on the strata manager. So we'll click on the strata manager, and what it does now, it lists me, for instance, if depending on whether I'm working on legend codes or geology codes or whatever, it lists me all the different geology types we have down all our borings or down all our holes. And the good thing is I'm going to show you, because I was working with, I opened this up as a blank drawing. You notice there's no surfaces in here. As I start clicking, it starts creating surfaces for me, both top and base for each set of data we're bringing in. Okay, so in seconds, from that imported data we just pulled in, if I just go back now and let's do this in a quick orbit. there we have our geology being pulled and being shown. Now, I have to give you some health warnings here. This is just the starting point of actually modeling the data, bringing the data in. You know, I've got some nice data here, all nice, beautiful strata, each one nicely layered. In the real world, it doesn't always come in like this, so you need to use AutoCAD Civil commands like drawing feature lines and break lines and adding them to your surfaces. By doing that, you can actually model and caress your geology data so it actually looks and forms correctly. If you get a chance in a couple of minutes, I'll show you a little bit about how that works. But you can see here that it's a great way of visualizing and bringing your geology in. And imagine we had our DTM here, we had a site plan here. We're looking at all this information in context with what we've got around the site. So it's a really fast way of doing this and seeing it. So there's hopefully that gives you a good idea. There's more we want to do, so just before we go on, I've got another poll question I want to ask you. So I think quite a lot of you said, 75% of the people I think said that you draw cross sections or you want to look at strata. So out of those who do that, I want a quick idea of how long it takes you to draw it at the moment. Okay, we'll leave it a little bit longer. There's a few who haven't voted yet. Need to. Okay, I think we're just about there. We have some very fast CAD operators here, up to 5 minutes. That's 18% of you. That's really good going, unless you're using the geotechnical module already. A third, or 36%, say up to an hour. 27% say over an hour, and 18% don't actually draw them. Okay, well, we actually have got some pretty fast operators. Normally when I ask that question, we get over 50%, say an hour or so plus on that one. But what I'll do is just try to show you just how quickly it is to do it with the geotechnical module now. And hopefully it will give you sort of at least an insight of just how quickly you can do it if you think you can make your processes a little bit more efficient. So we have this create geotechnical profile or geotechnical profile view wizard, which I'm going to quickly go through and show you that working now. So let's just go back into AutoCAD Civil. So I'm going to come here now. I'm just going to put it back into 2D wireframe and go back into top view again. So now we've got this data created. If we want to create myself a profile view, I just use this command here now called create profile view. I can tell it to hatch in individual stratas if I want to, or I could tell it not to hatch them, or just ticking on the boxes here. I can tell it which profile style I want to use. So here let's just use the standard major grids one. If you've got your own profile views, you could use those within AutoCAD Civil. And I'm going to click on here now, create alignment. So all I'm going to do is click a couple of points down my drawing where I want my alignment to go. Or I could pick an existing central road alignment or alignment that I have already drawn. So that will do for me now. It's now coming up and asking me what type of log strip do I want to generate. Let's use a legend code one here, shall we? And it's also saying buffer. So what it's looking is how far away from my central alignment would it look to project boreholes onto my alignment. So I can make that number nice and small so it won't find many, or I can make the number nice and large so it finds loads. Okay, so let's make it around about 50 and see what we get. Okay, so it's looking 50 feet either side of my central alignment, and it's going to project onto that alignment line. So if I just hit finish now, there we have my cross-section drawn in seconds. Now the beauty of this, the beauty of working here inside AutoCAD Civil, is this is all dynamic. Okay, so now I've done that. if I want to see what's going on around my site, I just drag my line to another location and it updates for me. Yeah, this is the great beauty of working inside Civil 3D. So, and it actually changes the way people work, because normally, when you generate cross sections, you're using it as to present to other people. It takes up to an hour. Some of you said over an hour. You don't have time to do this very quickly in a normal world. But now I can just pull in my geotechnical data and start generating profiles really, really quickly, and it allows me to see what's going on around my site very, very rapidly, okay, in doing it this way. So it's a different way of working compared to how you could work in the previous. So it's a real good benefit, a real positive way of working on it. So hopefully for those who sort of answered anywhere up to an hour or plus, you've got there a great way of saving an awful lot of time in working with these tools. So coming to the end of this section of the presentation, there are a couple of other things to quickly show you. The Geotechnical Hatch Manager. So for instance, how we are viewing the data down our borehole. So let me just come in here now to the Geotechnical Module again. I can go back here to my locations and tell it to show my strips on site again. So how are we displaying this data down here, sand, clay, etc. Or if I wanted to, I could come over here to the Style Manager and say, well, don't show it using those ones. Tell you what, display my log strips using my legend codes instead. So we hit Set Current on that, and in comes this information. The other thing we can do is just change the way we hatch everything. So let's come through here now to a Hatch Manager here. And let's look at one of these. Let's say find the clay. So we click on the button here and say to it, let's find anything equal to clay. Hit filter, and there we are. So we can see what color it's going to be in Civil in 3D. But we can also see how we want to hatch it in our log strips. Now if I wanted to, I could say to it, well, don't hatch it that way. Let's just do it as a cross hatch, shall we? Let's increase the size of a crosshatch to 5, do it that way. If I wanted to, we may want to have a more elaborate hatch by bringing in a second hatch over the top of it. So let's come down here, let's put some crosses over the top of it. Let's make that orange so we can see it. Change the scale of that to 5, etc. So now when we come in here and tell it to use my legend codes and go Set Current, you can see we now have this cross-hatching and the dots representing our material. So it's quite a sophisticated way of actually generating hatch styles and using those to show your material any way you really want to within the Geotechnical Module. We also have the ability to go into styles here, and we haven't got time to go through all this, but you can define how different symbols, different blocks get used for different boring types, what symbol, what labels you want to use, what size 3D sticks you want to show, and also what type of default plan strips. So for instance, here we've got legend codes being used. I can go and edit that. I can specify the scale in which my strips are shown, the relative size of the text to it, offset. So you've got quite a lot of control over how you want to show and govern information here. So the Geotechnical Module, it's really free or part of your subscription. There's an awful lot you can do to really help speed up the visualization of geotechnical data inside AutoCAD Civil 3D. So I hope you found that useful. What I want to do is just to finish this off is just tell you there are one or two about the limitations of it. So in fact, let's just quickly look at modeling geology. I've just noticed what the time is, so I need to do this quite quickly. I just want to quickly show you, I mentioned before, sometimes when you bring the data in, you have to do a little bit more work to it. So I'm just going to create a new drawing here, connect through, and I'm just going to have a quick look at a project I've got here. So we pull that data in, so you can just see the speed there. And what I'm going to try to show you here very quickly is, let's just put this into shaded view. can you see we have sort of the blue material is a rock, a sandstone across the whole site, but we then have this purple, and this purple is where gravel ends on our site. Now if I was to come in here now and generate a quick cross-section on that, so we'll just come in, we'll bring in our strata very quickly on our site, okay, like so. And what we'll do now is tell it to create a cross-section across my site. So here we come in here, create an alignment. Let's do it quickly through here. I'm going to let it hatch everything for me. We'll tell it to use, doesn't really matter which one, our legend code, put it over here. And you can see, because that was the last value it found down in my boreholes, or the gravel, we've got this great big void between the two here. Can you see? Because this void between the two. So the way we model this, and this is going to be incredibly fast, quick tuition, is to go into and draw a standard AutoCAD polyline. I'm just going to make sure I've got near snap on. I have indeed, and basically just say, well, I think the extent of my gravel probably comes around here somewhere and ends down here. So I just draw a simple polyline. I'm then going to come up here and convert that polyline into a feature line. Now the reason I'm doing it this way is I can come in here, I don't need it to be on a site, I won't style it, but I will assign it to an elevation, because if you look over here, we probably have the gravel will probably disappear into the green layer up here, which is my made ground. So I'll say to it, it just disappears into the base of my made ground. So now we have a feature line drawn just below my made ground, just there. So all I have to do now is to model this, is just say to it, well, add this feature line as a break line to the geologies it affects. So I've done it to the made ground there. So the purple is my gravel. So we just go gravel top, and you'll see it all suddenly change in a moment. We'll tell it to gravel base. You can see it's pinched the two together here, and I just need to finish it off now by going to sandstone top. Okay, so you can see it's all pinched together. I'll zoom in a little way so we can see it a little bit better. And the nice thing about this, if I now move that cross section to somewhere else, can you see where the gravel goes into the sandstone? It all pinches in correctly. Now you see there's more modeling I have to do, so it's the same principle again. And I've been looking at how to model this geology for many years now in AutoCAD, and actually it is just that same principle, that and perhaps using boundaries, and that's all we use to actually model the data. So it's a pretty quick process. So we're just about done. A couple of things I want to just quickly mention to you. There are limitations with the geotechnical module. For instance, it will only work on a local machine with a local database, okay? So if you've got teams, people working, you need to look at a different solution. It will only display certain downhole data, you know, the subsurface material, that's it, nothing else. You can't use it to visualize water locations, all that type of stuff. It's just purely working on borehole locations and material. And really, if your data changes, you notice a mistake, the ground level's changed, you can't just quickly update the data and see those changes inside the geotechnical module, okay? So it is very good for visualizing materials, perhaps for earthworks, once you have everything prepared, ready to go. But there are alternatives for it all. So for instance, just moving on a little bit, you know, Keynetix, we develop the geotechnical BIM solutions. So this is a range of software all based around geotechnical data that you can use for many different things. So for instance, our core product, which is a whole-based SI, which is a data management system, you can use it to prepare, work out where you want to put boreholes or borings in a desk study. You can use it to collate site investigation data and generate boring logs, really rapid, really easy to use. You can use it to schedule tests for labs, and we actually write lab management software as well, so your geotechnical labs can use our software, send it all back to Wholebase, so you've got all the data being managed. but then we make that data available into the geotechnical module, or we have a big brother for it to it called the whole-based SI extension for Civil 3D that allows you to do a few more things, and that data is seamlessly available inside of AutoCAD Civil 3D. Update the data in whole-base and you update the data inside Civil 3D. And we also have a very similar tool that works inside Excel, so it allows you to visualize and understand your numeric data in Excel, which is actually stored and managed in whole-base. So these are the type of things that whole-base does. So I mentioned to you, you can use it to plan where you want to put all your borings. Give this to your drilling teams, they go out and hopefully you'll get the data and your borehole data where you actually asked it to be drilled. In fact, the mapping interface, where you can see there, like Autodesk, we use Microsoft Bing mapping, so you can put that into your reports, apply it to your clients. You can also use this to highlight and show lab results, borehole locations, once you start bringing it in as well. We can generate quick sections within whole-base, not even touching AutoCAD, and a whole range of boring logs, or you can design your own boring logs and use those really fast. The software is really easy to use. I mentioned that it links out into Excel, so if you're managing your data inside whole-base, there's no importing and exporting. You actually in Excel, and it talks to whole-base and it pulls the data through, so it makes it very rapid at generating charts and visualizing and understanding what's going on with your geotechnical data. Update the data in whole-base, click the generate button inside Excel, and it's updated. We have the extension inside Civil 3D, so this one may be done with the Geotechnical Module, or it may have been used the whole-base extension. But as we move on, what about all the other data that you may want to manage? So here, we're just showing you potentially a way of showing high levels of contaminants, or it could be any other information, moisture level contents, anything you want across the site. We're bringing that data through and visualizing it inside AutoCAD Civil 3D. It's a really fast, simple process to do. On the right, what about all the other data you may want to show on a log strip? So here we've got core recovery information, we've got monitoring information, groundwater levels, sample IDs. That's just a very small sample of the type of information that you may want to come in and show. So if it's the type of stuff that you have to do here, then you'll find that the geotechnical module doesn't quite get as far as you need to, but there are other solutions that will take it past and allow you to do these extra things with your data. So, for instance, the whole-base SI extension for AutoCAD Civil 3D will allow you to share drawings across multiple computers, working with those linked into a central database, pulling information in. You can show things like N values, your SPT blow counts, its surface from it, show it in log strips, your water strikes, groundwater levels, CPT data, so the whole range of the information that you can access and show if you need to. Now, I am conscious of time. I think we probably came up to the end of the allotted thing. I could spend a minute or two showing you this, but I think probably you've seen the images there. We'll leave it at that point, and I'll open up Christian to see whether there's any questions or there's any feedback from anybody, anybody wants to know from it.
If you have any questions, please type it into the question.
Okay, while we're doing that, there is one other poll question just to finish it off. I'd just be really interested to know whether, if you guys are looking or your companies are working with geotechnical data, what other systems, software are you using to do that? Is it sort of something like GINT or Logplot? What are you using to do it, or are you just doing it in Excel? Okay, the numbers are coming in pretty quickly here. So 40% of you are having to manage all your data in Excel. Now, as we are keen on data management, I don't consider Excel data management. What about updates, versions? It takes you a long time. So there are big gains in productivity can be had by actually managing your data. 20% of you use other systems, just 10% use GINT, whether that's more personally or organization-wise, I don't know, and 30% I can quite understand. If you're coming at it from the CAD team, you don't always know what people are using in other parts of your organizations, but thank you so much for answering those questions. So Christian, so over to you. My apologies, I cut you off.
Oh, no problem. We have a three-part question. Can you edit the triangles?
So by that I mean, can you edit the surfaces that we are generating inside AutoCAD Civil 3D? So as such, that's what we just did here. I edited them en masse as opposed to doing them individually. You can do it individually. You can use your normal AutoCAD Civil techniques for editing surfaces that are generated. I generally prefer to use this technique because the beauty of it, and I won't do it now, but if I edit and move my feature line, all of my surfaces, all my materials will go with it at the same time. So it's a much easier way to manage the data. As you look at it and change it, you see things are slightly different. So yes, you can edit the triangles, but you would normally do it using these type of techniques.
Can you add QC data?
I have to hold my hand up and ask what do they mean by QC, quantity. I'm not 100% sure. Perhaps if the person wants to explain, it may be lost in translation between American and British on there, what you mean by that. So perhaps if the person who's asked that can just give me a quick insight what they mean. Oh, cool. Okay, rock recovery. Yes. You can't do it in the geotechnical module because it only works on hole locations and materials found down in the hole. But if you wanted to do that, you'd need to go over and use the hole-based SI and hole-based SI extension for Civil 3D. And you remember there was a log strip that we showed here, what was showing precisely that information. So if I just go back a slide or two here. This one here, that is what it's showing down here. Rock core recovery information is being shown down here on it. So that's stored inside the hole-based database, and we can then pull and show that information. And calculate volumes compared between, and yes, that is standard. So all volume calculation, etc., is really the standard bread and butter for Civil 3D. So once you've created these surfaces, you can generate volumes, you can compare. So a lot of users perhaps use it to work out volumes using the hole base, where we can also put contaminants in there. Quite often a common usage of people to digitize extents of contamination within a strata and work out the extents of contamination and how much needs to be cleaned and moved off and things like that as well. Someone's also mentioned about lab results data. I'm jumping ahead here. I'm starting to see you found where the questions are coming in. Yes, again, it's the same answer. I'm getting a little bit like a parrot repeating myself here. The geotechnical module can't, but all your lab result data can go off into hole base, and then we can pull that data and we can either show it down hole, as we've got in these examples here. We can show it, for instance, levels of pollutants across the site this way, or we can show it, for instance, down hole. So down this hole, this is the moisture content value that was found at this point in 3D down a hole. So there's various ways of doing it. So Christian, so back over to yourself.
We did have a comment saying what you were talking about seeing, we didn't see.
The sand, so at what point was that? Was my screen going too slow? So that may have been, I'm not sure where it was at, the modeling one that we were looking at here. It probably would have been one of the other projects I would have, oops. I pressed the wrong button here. What have I done? Can you see my screen okay, guys?
Yes.
Okay, I accidentally pressed the wrong button. So let me, I think that's probably been in one of the other projects. So I think what they mean is when I hatched and pulled in changed the hatching styles, they didn't actually notice that come through. So if I can do that very quickly now, I'm just going to connect through to our ASTI project we created earlier on. So now we've created it, you can see the speed it just comes in. I'm going to go to locations, I'm going to tell it to bring in my log strips. All I'm going to do here now is zoom in, and I'm just going to tell it to, instead of using the style I'm using at the moment, is to use my legend style. I think that's what we did before. May not. And there you can see, well, actually this is clay. I'm not sure this is what they're referring to, where we actually came in here and modified all the hatch styles, etc., that we were showing and displaying. I'm not sure that's what they're referring to or not, but hopefully it was. Any other questions?
Could this be a replacement for GINT?
I think not the geotechnical module on its own, can't be, but I think if you had to do this type of stuff, I draw boreholes, get data into AutoCAD Civil very rapidly, then the answer is very much yes. So yeah, I haven't really got time to show you now, but very quickly, if I click on the magic button, there we go, and I'm just going to go through to whole-based software, which is our sort of our GINT replacement. For those of you who have seen GINT, you'll see that this looks somewhat fresher in its feel and look at it. And this is going to be a 30-second demo, so it won't take very long at all to do. It's going to be a 45-second demo because I can't type in my password, so it's fully secured. And one of the big differences with our system is I have all of our projects on here. So I can go to any project, just open it up. So let's just see if we can find the one we've just been working on here. So there we go, one of our US ASTM configurations. So we've got all our data here. So I can import data here from GINT if I have to, CSV files, what we've just been looking at. We can enter data in here using our rapid data entry tools or from Excel. But once we have the data in here, if I want to generate a boring log, this is it, ready? Done. Okay, you can see the speed in which we can generate boring logs, pull this information in. If I don't like that style, I want to have my standard lab results being shown. I've updated it, and now we're showing another one. So for those of you who have got GINT or are looking for an alternative for it, very much is a great possibility. The big difference, of course, so this links directly into AutoCAD Civil, making your geotechnical data easily available and to visualize and work with inside AutoCAD Civil as well. Right, how are we doing with time? Any more questions?
We got a couple more. In the future, are you thinking about developing some kind of geostatistic model?
A geostatistic model? Not really. I think what they mean by that, I may be answering the wrong question here, so if I do, my apologies. When you're modeling data, there's really two techniques. There's an analytical approach you can take, which looks at the data and comes up with the answer for you, so tries to generate smooth surfaces around. It's something that is used quite often in mining, where there's loads and loads of boreholes or borings and lots of information. As you get lots of data, you can analyze it and start generating surfaces from it. Our software is primarily aimed at infrastructure, building roads, building bridges, stuff like that. You tend not to have so many borings in the locations, so you've got far less data to do it. So it's something which we've got an eye on, but we don't think we're going to go down that route. The route we think we are going to take, and we're working on now, is actually tools for you to actually edit your 3D model from your cross-section. So as you create a profile view, at the moment, you remember your profile views are normally dynamic. You can make them static, but then if you change them, your model, your 3D data doesn't change. Well, we're working on the method, so as you change it, it automatically updates your 3D model. So you just keep moving your profile view, look at another place, and digitize there what you want it to do. Then on top of that, we're also building tools to generate sort of lenses and outcrops of geology really rapidly. You just draw the extents of the geology, click on it, tell it which geology it's supposed to be, and it actually does all the work you saw me do before with feature lines and break lines. It does it all automatically. So we've got guys chained to the desk in the UK. They're not allowed to leave or see daylight until they've got this stuff working, so they're working hard trying to get this all done. It's not available just yet, but in the next hopefully a few months just after Christmas, we should be able to make it available for people. If that was the right answer, the question they were asking.
So looks like we got a couple more questions here. How is it licensed?
How is it licensed? Okay, well the Geotechnical Module is licensed directly by Autodesk through your normal subscriptions. The stuff that I've been talking about with WholeBase and the WholeBase SI extension for Civil 3D, they are sub-based licenses like normal AutoCAD. What we do though is we make them what we call global floating license. So as long as you can reach your license server, any office, any person can float it and use that license. Obviously you've got one person at a time, two people at a time. We don't restrict it to individual offices or to individual countries. So as long as it's available somewhere, someone's got it, you can start using it that way.
And could you shed some light on some major projects this has been used on?
Okay. I'm not au fait with major projects in the US, although having said that, I think I'm trying to think. There was a major sewer works, I think in San Francisco. One of our US customers has recently used it on. In the UK though, you know, probably one of the biggest projects is the Olympics. The Olympics Park is being used on that. There's a very recent project that is still ongoing. There is a tunnel underneath the River Thames called the Silvertown Tunnel. It's been used on that. There is there's many major bridges around the world. One's between Hong Kong and China, for instance. It was used on that. So many of the world's major infrastructures in the UK and around the world. Quite often, to be honest with you, a lot of the main users at the moment are UK-orientated UK construction companies, but we're getting major uptake now in the US. In fact, we have now 4 DOTs who are now actually using either KeyLab, geotechnical data management software, or WholeBase. So it's starting to get really rapid traction in the US, because I think there's quite a lot of people who want to work with geotechnical data, have a really simple to use system, but can then integrate it and make the most out of AutoCAD Civil 3D and the Autodesk software as well.